Welcome to Applications of Derivatives, Lesson 6, where we talk about curve sketching. We will use first derivative to find relative extrema. We'll use the second derivative to find points of inflection. We'll find the zeros to see where the graph of the function goes across the y-axis. So in order to do curve sketching, we need to do the following things. We need to find the domain, if applicable. We need to find all extrema. We need to find all points of inflection. And we need to find all zeros. So let's go ahead and move on. Alright, f of x equals x to the fourth minus 32x squared plus 31. Number 1. What is the domain of that function? Well, the domain of any polynomial function is negative infinity to infinity. 2. Let's find all relative extrema. What is f prime of x? 4x cubed minus 64x. I would like you to set that derivative equal to 0 and find where there are possible relative extrema. Alright, and then use the first derivative test to find out if they're relative minimums or relative maximums. So go ahead and pause and do that. Okay, those are the values that I found for x. I've got my first derivative test ready to go, and I can already tell you the values I'm going to use. I'm going to use negative 10, negative 1, 1, and 10 because those are convenient numbers to use. So go ahead and do the first derivative test. Using the first derivative test, I found that there's a relative minimum at x equals negative 4, a relative maximum at x equals 0, a relative minimum at x equals 4. Now I would like you to find the coordinates of those points on the graph of f of x. So go ahead and put these values back into the original f of x to find out what the coordinates of those relative mins and maxes are. And then come on back. Those are the values I got. Negative 4, negative 225, 0, 31, and 4, negative 225. Those are where there are relative extrema. 3. I need to find all points of inflection. So we're going to take the second derivative of f of x. That'll be 12x squared minus 64. Go ahead and solve for x. And then come on back. Okay. Second derivative, I got plus or minus 2.30940. Now we're going to use the second derivative test to find out if those are points of inflection or not. Negative 4 root 3 over 3 and positive 4 root 3 over 3. So let's pick negative 10. That would be 100 times 12, 1200 minus 64. That's positive. Let's pick 0 here. That would be negative 64, negative. And if we pick 10 again, we're going to get 1200 minus 64, which will be positive. So at both of these values, negative 4 root 3 over 3, 4 root 3 over 3, we have points of inflection where the f of x changes from concave up to concave down, and then at 4 root 3 over 3 it changes from concave down to concave up. And I think the last thing that we need to do is find the zeros of that function. So we have f of x equaling x to the 4th minus 32x squared plus 31. Trying to find the zeros. It's a nice factorable function going on there, x squared times x squared. Let me think. 2 factors of 31 that add up to negative 32. How about negative 1 and negative 31? So x squared minus 1 equals 0. X plus 1 times x minus 1 equals 0. X equals plus or minus 1. X squared equals 31. X equals plus or minus root 31. So we need that as a decimal so we can graph it. 5 point. Hold on a minute. There you go. Just a little bit over 5.5, and that should be plus and minus. All right. Now I think we're ready to graph this function with everything that we have. Let's go ahead and graph these zeros first. That'll be the best thing to do. Alright, we need to set some boundaries here. Every 2 will be 1. So this is negative 1, negative 3, negative 5, 1, 2, 3, 4, 5. Okay. Actually, we need points, so let's go back and find some points here. We have points for our relative mins and maxes. We do not have points for our points of inflection yet. So let's go ahead and find the coordinates of the points for our inflection points. So negative 2.30940 and 2.30940. Let's find the y values by putting those back into the original function. Alright, come on back and we'll find those. Pause, please. Okay, both of those values were negative 110. And we also need to find the values at plus or minus 1, plus or minus root 31. So those points are negative 1 something, 1 something, negative root 31 something, and root 31, which is 5.5 or 5.6. Alright, go ahead and find those values so we can actually graph these points. Pause. Of course, those are zeros because that's what we found. We're zeros. So let's first go ahead and graph those 4 zeros right here. Let's graph those first. Okay. Negative 1, 0. 1, 0. Negative 5.6. There's a 0. And negative 5.6 here. So that is where the graph crosses the x-axis. Alright, now the other points, the relative extrema, let's see what those are. we got to go down to negative 225, go up to 31, and then the points of inflection we got to go down to 110. So what do you think we're going to make on a scale here? I'm thinking that we should go probably every 50 here. So 50, 100, 150, there's 200, negative 50, negative 100, negative 150, negative 200. Alright, let's see here. It was 0.31, a little bit more than 25, right about there. And then let's see here, we had negative, well, can't remember, negative 4, negative 225, negative 4, negative 225, 200, right there, positive 4, negative 225, right there. Okay, we have a point of inflection at negative 2.3. Okay, this is 2.5, 2.3, negative 110, a little bit less than, right about there. And at 2.3, right about there, negative 110, right about there. Alright, now bear with me. From here to there, it is concave down. So we'll try to draw this concave down. Whoa. Points of inflection. From here it's going to change to concave up. So it changes to concave up, goes right down there at that relative maximum. Come on, this is not easy to do with this slate. That was pretty doggone close. I missed it by a little bit. I guess I could try to fix it a little bit. Yeah, right. It is not easy to write with the thing. It's a lot easier to do on the board. And then it's going to be concave up. Wow. This is not as easy as it looks. I don't think I can do this, you guys. Wow. Alright, I'm going to pause and try it. I'll try to redo the whole thing, so I'll be right back. There you go, like a SpongeBob episode. 3 hours later, I think I've got it pretty close. Notice that from this point of inflection, it's concave down to that point of inflection. And then for the rest of it, on both sides, it's concave up. And that is the first section on curve sketching. Please continue on to part B with curve sketching. We'll do a trig function. I can't do it in a minute and a half, so let's go ahead and move on to the next one.